to realise that these early archaeologists were themselves myth makers. And so one of the fascinating things about studying Minoan Crete is that you're often untangling the myths not only from early Greece, but also the myths which have come down from some of these archaeologists, Arthur Evans included.
Long before artificial intelligence entered the story, the mystery of the Minoans was already tangled in another mystery: the stories created by the people who first excavated their world. Early archaeologists did more than uncover ruins. They also interpreted them, sometimes filling gaps in the evidence with assumptions that later generations had to untangle. Sir Arthur Evans, the British archaeologist who excavated Knossos, famously gave the civilization its modern name, Minoan, connecting the archaeological remains to the legendary King Minos of Greek mythology. Today, archaeologists are much more cautious about separating what the ancient evidence actually tells us from the interpretations imposed upon it by later scholars. And nowhere is that problem more fascinating than with the Phaistos Disc, one of the most enigmatic objects ever recovered from Bronze Age Crete. The story of the disc begins in 1908, when Italian archaeologist Luigi Pernier was excavating the ruins of the Minoan palace at Phaistos on the southern coast of Crete. Phaistos was not an insignificant settlement. It was one of the major centers of Minoan civilization, a culture that flourished across Crete during the Bronze Age, centuries before classical Athens and the Greece familiar from later history. Inside a room associated with the palace complex, Pernier's team discovered a small circular object made from fired clay. At first glance, it looked almost ordinary, but its surface was covered with strange symbols, arranged in spiraling sequences. And unlike the inscriptions found on many other Minoan objects, these signs did not belong to any writing system that scholars could confidently identify. The disc measures roughly 16 centimeters across, about 6.3 inches, making it small enough to fit comfortably in one hand. Yet its surface contains an astonishing amount of information. Both faces are decorated with signs arranged along a spiral that moves toward the center. Scholars have identified 241 individual impressions made from approximately 45 distinct sign types. Some appear vaguely recognizable: human figures, animals, plants, weapons, and geometric forms. Others are so stylized that their original meaning remains impossible to determine with confidence. But the appearance of the symbols is only the beginning of the mystery. What truly distinguishes the Phaistos disc is the method apparently used to create them. Rather than carving every symbol individually into the clay, whoever manufactured the object appears to have pressed individual sign stamps into the soft surface. In other words, a particular symbol could be produced repeatedly using the same carved tool. This is why the disc has sometimes been compared, cautiously, to a primitive form of movable type. The comparison should not be taken too literally. There was no printing press, no ink, and no paper in Bronze Age Crete. Yet the basic concept of using a reusable symbol-producing tool is remarkably sophisticated for its time. If the interpretation is correct, the maker was not simply writing one mark after another. They were working with a system of standardized signs and deliberately reproducing those signs across the clay. Even more remarkable is the fact that the disc survived at all. Much of the clay used by the Minoans was not fired deliberately and therefore could deteriorate relatively easily over thousands of years. The Phaistos disc, however, was hardened by firing. Archaeologists have proposed that this may have happened during one of the destructive events that affected the palace. A fire or other high-temperature event could have transformed the clay from a vulnerable object into something capable of surviving for millennia. In a strange twist of history, a disaster that may have contributed to the destruction of part of Phaistos could also have preserved the object, that would eventually become one of archaeology's greatest puzzles. But the disc's survival created a problem as much as it created an opportunity. More than a century after its discovery, scholars still cannot say with certainty what the symbols mean. The issue is not that archaeologists and linguists have ignored the object, quite the opposite. The Phaistos Disc has attracted generations of researchers, amateur decipherers, linguists, historians, mathematicians, and enthusiasts who have attempted to identify its underlying system. Yet no proposed reading has gained the kind of broad scholarly acceptance required to call the disc deciphered. The reason becomes clearer when we compare the disc with one of the greatest decipherment successes in archaeological history, the Rosetta Stone. Egyptian hieroglyphs were not solved simply because scholars suddenly became better at recognizing pictures. The breakthrough came because the Rosetta Stone contained essentially the same decree in 3 scripts, including Greek, a language scholars could already read. The known Greek text provided a bridge into the unknown Egyptian writing systems. By comparing repeated names, phrases, and structures across the versions, researchers could gradually identify the meaning of individual signs and grammatical patterns. The Phaistos Disc offers nothing comparable. There is no bilingual inscription providing a translation key. There is no second disc containing the same message in a known language. There is no large collection of inscriptions written in the exact same sign system that scholars can compare across different contexts. Instead, researchers are confronted with a single object containing just 241 sign impressions. That is an extraordinarily small dataset for deciphering an unknown writing system. This is the central reason the mystery has survived for so long. Imagine finding a single page from a book written in a completely unknown language, while having no idea who wrote it, what language family it belongs to, or whether the marks are even writing. You could analyze every symbol, count every repetition, map every sequence, and compare the patterns with thousands of known languages. But without additional examples, it would be extremely difficult to distinguish a genuine linguistic relationship from coincidence. And that uncertainty raises an even deeper question. Is the Phaistos Disc actually writing? For more than a century, researchers have proposed radically different explanations. Some believe it records a religious hymn or ceremonial text. Others have suggested a prayer, ritual chant, administrative record, calendar, or some other form of organized information. There have even been proposals that the object was not intended to communicate language at all. Its unusual layout has led some researchers to consider whether it could have served a practical or ritual purpose, rather than functioning as a conventional written document. That possibility changes the entire nature of the mystery. If the disc is writing, the central challenge is deciphering an unknown script. But if it is not writing, then every attempt to translate its symbols could be based on a false assumption from the beginning. This is why the Phaistos Disc remains so important. The mystery is not simply that we cannot read it. We do not yet know with certainty what kind of communication system, if any, we are looking at. It could contain a language, a religious formula, an administrative record, a symbolic sequence, or something whose purpose modern researchers have not yet imagined. And this is where the story begins to connect with the technology of the present. For generations, scholars had to examine these symbols largely by hand. They could photograph the disc, draw the signs, compare their positions, count repetitions, and construct theories from the available evidence. Modern computational methods have changed the scale of that process. Artificial intelligence can examine patterns across an entire dataset, identify recurring sequences, measure symbol frequencies, and test statistical relationships far faster than a human researcher working one symbol at a time. But there is an important distinction. AI can help determine whether patterns exist. It can test whether certain sequences behave like linguistic structures. It can compare the statistical characteristics of the disk with known writing systems. What it cannot do is magically produce a verified translation when the underlying evidence is insufficient. The Phaistos Disc therefore represents something much more interesting than a simple ancient code waiting for a clever computer to crack. It is a test of how far modern technology can go when confronted with an ancient object that provides almost none of the clues normally required for decipherment. For more than 3,700 years, the people who created those symbols have remained silent. Their palaces, artwork, pottery, and objects have given archaeologists glimpses into their world, but the words behind that civilization remain largely inaccessible. The Phaistos Disc sits at the heart of that silence, a small piece of fired clay covered in 241 mysterious impressions created by people who almost certainly understood exactly what those marks meant. We do not. And that is what makes the disc so compelling. Somewhere within those spiraling symbols may be a message from the Bronze Age, perhaps a religious text, perhaps an administrative record, perhaps something entirely different. Or perhaps the greatest discovery will be realizing that we have been asking the wrong question all along. The real breakthrough may not come when someone finally tells us what the Phaistos Disc says. It may come when we finally understand what the object was meant to do. The Phaistos Disc has none of the advantages that helped unlock other ancient writing systems. There is no Rosetta Stone equivalent waiting beside it, no bilingual inscription pairing its mysterious symbols with a known language, and no confirmed descendant script that clearly evolved from the same system. Most striking of all, only one surviving object is known to contain this particular sequence of signs. After more than a century of archaeological investigation, researchers still have no second example that could provide a meaningful comparison. And that single fact may be the greatest obstacle standing between us and the disc's secret. For linguists, decipherment usually depends on volume. Researchers need enough inscriptions to observe how signs behave in different contexts, how frequently they appear, which symbols occur together, and whether certain sequences repeat in ways that resemble words, grammatical endings, or phrases. The more examples available, the easier it becomes to separate genuine patterns from coincidence. The Phaistos Disc offers almost none of that statistical breathing room. Its 241 individual sign impressions may look like a substantial amount of information, but for an unknown writing system, they represent an extremely small sample. It is almost like being handed a single page torn from a book, written in a language nobody has ever encountered, with no other pages, no author, and no library containing related texts. You can examine every mark under a microscope, measure every curve, and catalog every repeated symbol. But without additional material, there is only so much that even the most talented linguist can prove. And there is another complication. The mystery surrounding the Minoans has never been limited to their writing. Early archaeologists were also trying to understand an unfamiliar civilization using fragmentary evidence, and their interpretations sometimes became part of the story itself. Arthur Evans, for example, played an enormous role in shaping the modern understanding of Minoan Crete, but later generations of scholars have had to separate archaeological evidence from some of the assumptions and narratives imposed upon it. Even seemingly ordinary images and objects were interpreted through the expectations of their time. Researchers examined representations of women, domestic activities, rituals, and everyday life, attempting to reconstruct an entire civilization from fragments. In that sense, studying the Phaistos Disc is not simply an attempt to read an ancient object. It is also an attempt to strip away more than a century of modern assumptions and determine what the evidence actually allows us to say. And if that mystery is already enough to keep you hooked, subscribe now, because the deeper we go into what this object actually is, the stranger the story becomes. The biggest question is one that sounds surprisingly simple. Is the Phaistos Disc even a writing system? That is where the mystery takes another unexpected turn. Scholars do not merely disagree about what the symbols mean. They disagree about what the object itself was designed to do. Over the decades, researchers have proposed a remarkable range of possibilities. Some have argued that the disc contains a religious hymn, perhaps intended to be recited during a ceremony. Others have suggested that it could represent a ritual chant, meaning that the symbols were not necessarily recording ordinary written language, but preserving something intended to be spoken or sung. Another possibility is that it was administrative, perhaps recording information about goods, resources, or activities within the palace system. Some have even suggested that its circular structure could have been associated with a calendar or another method of tracking recurring cycles. Then there is the theory that changes the entire question. Perhaps the Phaistos Disc was never a text at all. One interpretation proposes that the object could have been some kind of game board or game-related device. The idea is not entirely new. Soon after the disc was discovered, Italian archaeologist Alessandro della Seta reportedly noticed that its rigidly organized compartments and circular arrangement looked unusual enough to consider a non-literary purpose. Instead of assuming that every symbol represented language, this approach asks whether the marks could have formed part of a structured activity governed by rules. For decades, however, the possibility attracted far less attention than the much more tantalizing idea that the disc contained a hidden Bronze Age message waiting to be deciphered. More recently, the possibility has returned to the discussion through renewed analysis of the disc's physical structure. Researchers examining the object with modern techniques have focused not only on the symbols themselves, but on their arrangement, manufacturing process, and spatial relationships. The important question is whether the physical organization of the disc behaves like a written document or something designed to be interacted with. If the arrangement follows rules that make more sense for a game, ritual device, or other structured object, then the traditional assumption that the disc is simply a piece of writing becomes much harder to defend. Some of the observations are particularly intriguing. The signs appear tightly organized within defined compartments, creating a remarkably controlled visual structure. There are no obvious signs of correction or spontaneous alteration that might be expected when someone is composing a text and changing their thoughts as they go. The orientation of certain figures is also unusual. Signs along the outer portion of the spiral appear consistently oriented outward, while the organization of the inner spiral follows a different direction. These details do not prove that the disc was a game board, but they demonstrate why its physical design deserves as much attention as its symbols. And that distinction is crucial. A strange arrangement does not automatically reveal an ancient game, just as recognizable-looking symbols do not automatically prove that they represent words. Archaeology is filled with objects that appear obvious until additional evidence changes the interpretation. The Phaistos Disc demands exactly that kind of caution. Every theory has to explain not only the symbols, but also their number, repetition, orientation, spacing, manufacturing technique, and the extraordinary decision to arrange them along a spiral. So, more than a century after Luigi Pernier uncovered the object at Phaistos, researchers are still facing a question that should have been answered long ago. What exactly are we looking at? A written language? A religious text? A ceremonial object? An administrative record? A calendar? A game? Or something for which modern archaeology does not yet have the correct category? That is what makes the Phaistos Disc so different from a conventional undeciphered inscription. The mystery is not simply locked inside the symbols. The mystery begins before translation even starts. We first have to establish whether the symbols are communicating language in the way we understand writing to communicate. And that may be the most important question of all, because if the disc is not actually a written message, then every attempt to decode it could be solving the wrong problem. The real mystery is, therefore, not simply, what does the Phaistos Disc say? It is much more unsettling. Does it say anything at all in the way we usually mean that phrase? The question of whether the Phaistos Disc is actually writing leads naturally to another question. What happens when we give the problem to a machine? For more than a century, decipherment depended heavily on the trained intuition of specialists. Linguists and archaeologists would spend years studying individual signs, recording their shapes, counting how often they appeared, and comparing their positions with symbols from other ancient scripts. The process was painstaking and often depended on a researcher's ability to recognize patterns that might not be obvious to anyone else. Every hypothesis had to be built piece by piece, sign by sign, comparison by comparison. It was a method capable of producing extraordinary breakthroughs, but it was also limited by the amount of information a human could realistically examine. Computational analysis changes that equation dramatically. A computer can examine an entire collection of symbols simultaneously, searching for repetitions and structural relationships that would take a human researcher an enormous amount of time to identify manually. Algorithms can measure how frequently individual signs appear, determine which symbols repeatedly occur next to one another, identify recurring sequences, and examine whether particular groups of signs behave in ways that resemble words or grammatical structures. Researchers can also test competing linguistic hypotheses against the same dataset, rather than relying entirely on visual intuition or subjective resemblance. This is not simply a futuristic idea. Computational approaches to ancient writing are already an established area of research. Scholars have increasingly used machine learning, statistical analysis, image processing, and pattern recognition to investigate undeciphered or damaged writing systems. The broader field includes Bronze Age Aegean scripts such as Linear A, Linear B, and Cypro-Minoan, as well as the mysterious symbols associated with the Phaistos Disc. Modern technology does not replace archaeological expertise, but it gives researchers a completely different way to interrogate the evidence. The progress made with other ancient scripts demonstrates why researchers are taking these methods seriously. In 2019, researchers from MIT and Google explored machine learning techniques designed to assist with the decipherment of ancient languages, including experiments involving Linear B and Ugaritic. Then, in 2022, researchers introduced Ithaca, a deep learning system developed by Google DeepMind and collaborators. Published in Nature, the system demonstrated how artificial intelligence could assist historians in restoring damaged ancient Greek inscriptions and estimating aspects of their geographical and chronological origins. These breakthroughs did not mean that AI had suddenly learned to read every forgotten language. Instead, they showed something more practical. Computers could become powerful analytical partners in the process of reconstructing the ancient past. That distinction matters enormously when the subject is the Phaistos Disc. AI does not possess a magical dictionary hidden somewhere inside its algorithms. It cannot simply look at an unknown symbol and announce its meaning with certainty. What it can do is test enormous numbers of possible relationships between signs and sequences. A computer can examine patterns across the entire object, compare frequencies, measure distances between symbols, and determine whether particular arrangements are statistically unusual. It can identify patterns that a human researcher might spend years searching for manually, or perhaps never notice at all. But there is a line that should not be crossed. AI can test a hypothesis. It cannot automatically turn that hypothesis into a verified translation. That difference is easy to lose in a sensational headline. When a computer discovers that two ancient scripts share certain statistical characteristics, that is interesting. When an algorithm identifies a recurring sequence that resembles a linguistic structure, that is potentially important. But neither result, by itself, tells us what the symbols actually mean. A genuine decipherment requires much stronger evidence, ideally evidence that can be independently tested and reproduced by other researchers. So, what happens when these computational methods are applied specifically to the Phaistos Disc? One of the most intriguing possibilities involves Linear A, the still undeciphered writing system used by the Minoans on Crete and elsewhere in the Aegean. Linear A is not the same script as the Phaistos Disc's signs, and researchers cannot simply assume that the two represent the same language or writing system. Yet Linear A provides something the Phaistos Disc desperately lacks: a much larger collection of inscriptions. Linear A appears on tablets, seals, vessels, and other objects discovered at numerous archaeological sites. Although scholars still cannot read the language with confidence, the quantity and variety of surviving inscriptions allow researchers to study how its signs behave. They can examine recurring sequences, symbol frequencies, combinations, and positional patterns. That gives computational researchers a statistical baseline that simply does not exist for the Phaistos Disc. The question, therefore, is not necessarily, can Linear A translate the Phaistos Disc? That would be far too strong a claim. The more scientifically useful question is, does the structure of the Phaistos Disc show statistical characteristics that resemble Linear A more closely than we would expect by chance? Even a modest relationship could be significant. It would not suddenly reveal the meaning of the disc's symbols, but it might provide evidence about the type of system the object represents. If the statistical behavior of its signs repeatedly echoes patterns found in known Minoan writing, researchers would have another piece of evidence suggesting that the disc belongs within the broader writing traditions of Bronze Age Crete. If the patterns looked fundamentally different, that would be important too. And researchers can examine the disc without comparing it to Linear A at all. True.